Alright, this is just a brief introduction to quadratic equations. Probably in your algebraic history you've been learning a lot of linear equations, and what basically makes them linear is that they have an x to the 1 power, which you really don't usually write anyways, but you're probably used to y equals mx plus b, and you'll have an x and a y, and you'll have some numbers and that sort of thing, so you might have something like this, and that would look normal to you. They make a straight line. What we're going to do with quadratics, they have x squareds in them. So your equation would look something like this: y equals 3x squared plus or minus 2x plus 1. And that would make a parabola. And a parabola looks like this. Parabola. Parabola. That's the graph that it makes. So a quadratic equation makes a parabola. Sometimes the parabolas, when we graph them, are upside down. You didn't have to really worry about that so much with lines. You had to worry about positive lines and negative lines. Parabolas, you worry about this type of parabola, a smiley face one. There's a real technical term. Or a frowny face. Opening up, opening down. Either way. So the standard equation, and again you should take your notes out, make sure you have this stuff in there. The standard equation, what you've seen before for lines, it looks like this: ax plus by equals c. You probably didn't see that so much, but for a quadratic one, it looks a little bit messy, but the more you get into quadratics, the more you'll get used to it. It's ax squared plus bx plus c equals 0. And we'll use that quite a bit once you get into all the different things you can do with quadratic equations. So this should be fairly new to you, this right here. So make sure you have that written down. The thing that's important about it is it's such a standard equation that the a is always written before the x squared, the b is always written in front of the x, and the c is always by itself. And we'll get into that a lot more as we tackle other topics with quadratics, not in this video, but in other videos. Alright, I want to talk a little bit more about some of the parts of the graph. And so I'm just going to draw one. And this parabola is just going to come down and zing like that, and go back up. Remember, this is your y-axis, that's your x-axis. So what are some of the parts here? This bottoming out part right here, the very, very bottom part, is called the vertex. And if your parabola opens up like this one does, he opens up, or she, your vertex is going to be the bottom part. If you had a parabola that is like the frowny face kind, this would be your vertex here, and that would be the highest point. Alright, there are two other things that's important in this case, in the picture that I drew, and that's this guy here and this guy here. And those are called either your x-intercepts, that's one word. We also call them solutions. And just to make it really vague, we also call them roots. All three of these terms refer to the place where the graph crosses the x-axis. So they can be used interchangeably in general format, and that's something that's good to keep involved, because they're like, solve this quadratic equation. Sometimes it helps to be able to say, oh, you mean find the roots? I get that. The other thing about parabolas is they do have symmetry. So right through the vertex is your line of symmetry. In other words, if you fold the parabola over on the vertex, it would match up. One side would completely match the other side, so it does have symmetry. Some textbooks go into it and they want you to find the axis of symmetry, which if you can find the vertex, you can totally find the axis of symmetry, no problem. The way to find the vertex will be covered in another video, so you don't have to worry about that now. Just keep in mind that it is symmetric. Alright, while we're talking about roots or x-intercepts, I want to show you that there's a couple of different types of parabolas that we can have. And let me draw my xy axis again. Alright, we have the parabola like I just showed you, where we have two roots. And so you can see that you have one root here, and you have one root here. So in that case, we have two roots. There's another type of parabola. It doesn't have to be an upside down one. I'll draw it here though. Or I could draw one up here too, it doesn't matter. What do you notice about these parabolas? These parabolas have no roots. They are never, ever, ever gonna cross that x-axis. They're just gonna keep on going. This guy here is gonna keep going down in a negative direction. This guy here is gonna keep going up. And they're never gonna hit the x-axis, ever. So since they have no x-intercepts, they can't have any roots. So that's another case. You can have two roots, you can have no roots, and yes indeed, let me find another color here, I'll do orange. There is one more case, and that case could look like this. Let's see. And this just kisses, yep, go ahead, snicker, I said kiss. This kisses the x-axis. And in that case, it only has one root. Keep hitting that button with my wrist. So you can have two roots. This is what this is the main gist of this. Or you can have one root, or you can have no roots. And those are good to know because as we get into more advanced things to do with quadratics, they're going to ask you to be able to determine that algebraically, which is actually just through doing some order of operations, and then to be able to envision it in your head and translate it. Well, what the heck does it? So I found out it's got one root. What does that mean? And to be able to picture that it's a parabola that just comes and kisses that x-axis, it doesn't cross it, it only hits it in one spot. Excuse me. That's totally what you need to get out of that. All right, I think I'm going to talk about one more thing. There's a lot to talk about, honestly, with quadratics, but one thing that I think is fairly okay to get, and it's a pretty good intro topic, is I want to go back to this ax squared plus bx plus c. And I want you to equal 0. And I want you to be able to tell, just by looking at its equation, whether the parabola will open up or open down. So here are the rules. And again, get this in your notebook. So parabola will open up if your a value is greater than 0. So if a is a positive number, your parabola is going to be a smiley face. Think about it. It's smiling because it's positive. I'll put that in parentheses. Smile equals positive, or positive equals smile. A parabola will open down if your a value is less than 0. It's frowning because it's negative. Alright, so I know some of you guys are out there going, alright, if it's greater than 0, this, if it's less than 0, that. What happens if a is equal to 0? If a equals 0, it means that this term here is completely gone, and that means that we would end up with a line. So if a equals 0, we have a line. In case you wanted to know. So get that in your notes, and I think I'll just write down a couple of equations, and you guys can tell me, or I guess we can figure it out together since I can't hear you. You can tell me if they open up or down, or we can determine that together. So let me slide this guy up. Okay. So here we go. Let's say that we have 3x squared minus 5x plus 4 equals 0. Will this guy open up or down? It's real easy. You look at this. 3 is positive, so it's going to open up. It's just that simple. Here's another example. Negative 10x squared. Yeah, I know. You're already yelling the answer at me, aren't you? Alright, does it open up or down? Look at this guy. He's negative. He's going to open down. So far, so good? Alright. Actually, I want to scoot that guy up. Alright. Give me a chance to write this one. Don't holler at me yet. Let's try this one. 5x minus 6x squared plus 1. Ha! Up or down? Did I fool you or not? I know, I was really tricky. I put the x squared in the middle. That negative sign is married to the 6. So our a value is negative, so it's going to open down. Ha ha ha. Can't fool you. Alright, let's try 2 more. How about 12 minus 13x plus 4x squared equals 0. Up or down? Again, look at the number in front of the x squared. It's positive. It's going to open up. And I do have one more that I want to run by you. let's see. Let's do 3x squared minus 5x plus 1 equals 7x squared. Aha! You had to let me finish it. Does it open up or down? Well, you don't really know yet. Why? Because we have to have everything all on one side of the equation. So we need to bring this 7x squared over. Which term do you combine it with? X squareds can only combine with x squareds. So you bring it over here. Now let's rewrite. 3x squared minus 7x squared, negative 4. I bet you don't want me to write any more. I don't need to, do I? So now we know that that equals 0. And what's our a value now? It's a negative 4. So just be careful. Just keep an eye out. Remember all these little tricks. And I hope that helps. It's just the basics of quadratics, real basics. And we'll be diving into a lot more other topics on other videos. Thanks.